All right, hello folks. Let's go ahead and talk about something you're going to see. We're not going to get too much into the calculations, but I need to let you know what these things are. Polyatomic acids. By definition, when we talk about polyatomic acid, and come on pen, acid that can donate more than, can't spell today, 1 proton. And what do I mean by that? So let's take a look at this. This is a polyatomic acid, H2SO4, sulfuric acid. So what we have the first reaction occur, and this is in equilibrium, and it's H plus H SO4 minus. And we have a Ka, and we're going to call this Ka1, the first dissociation constant. And now, HSO4 minus can also react to form H plus SO4 2 minus, and this is going to be Ka2. So this is what we mean by polyatomic acids and bases, that we actually have two types of reaction occurring, and at any given time we're going to have a concentration of this, we're going to have a concentration of this, and we're also going to have a concentration of this. For the most part, if you start off with HS2O4, you'll have some of this and almost none of this. Even though you do have this reaction occurring, it's very, very low amount of SO4 2 minus produced, because it tends to go more in this direction. For this to, you have to take away protons to get react with something to react with this, mainly a base, to get to here, and then this will go to this or go to this. So you got to go in both ways. So here's the acid, here's the conjugate base, but that conjugate base also acts as an acid to this conjugate base, and vice versa. So this is what we call polyatomic acids and bases. Now, polyatomic base are going to be a little bit more rare because we got not that many bases that are soluble in water, but we've got calcium hydroxide. So CaOH2. You can have KB1, where it's going to be CaOH minus plus OH minus. And then we have the second base association, where we're going to end up with, this is Ca2 plus OH minus again. And so this is Kb2. And we have these type of reaction occurring. More likely going to see this type of polyatomic base where nitrogen, you have two nitrogen groups on a carbon chain. This is one type of polyatomic bases you'll see. Again, this is actually rare to see. We actually see polyatomic acids more often than we do a polyatomic base, especially in this class. And we're not going to do so much with this type of chemistry or this type of calculations because it's a little more for sophomore level chemistry in college. But I do want to point out that amino acids contain both an acid and base in the molecule. So that's called a Zwitter ion. This is Germany, meaning both acids contains positive and negative. So if you draw an amino acid, this is glycine. It's going to have this type of structure. Here's the basic portion. This is the acid portion. And you can see that in chemistry, both of these can react in water to form H3N plus, CO2 minus, and here's an H, and here's an H. So we have that type of chemistry. Again, we're not going to do this in this class. I want you to be aware of these type of structures, aware that this can occur, but the calculations that we're going to do will not enter these things because this is more of a sophomore level chemistry in college. But you need to be aware of some of the stuff that you're going to be looking forward to if you take chemistry in college. All right? Thanks, guys.